Let us start with hybridization. First, we'll talk about Sp3 type of hybridization. There are three different types of hybridization: Sp3, Sp2, and Sp. So we'll start with first with Sp3 hybridization. So in this type of hybridization, 1s and 3p orbitals. And these three orbitals, they are having comparable energies. Comparable energies. It's nearly same energies. Having comparable energies. They recast to form Sp3 hybrid orbitals. Sp3 hybrid orbitals. There is a recasting of orbitals. Means these S and P atomic orbitals, they recast themselves to form Sp3 hybrid orbitals. Now, as you all know, S orbital is spherically symmetrical, while Px, Py, and Pz, these are the orbitals having two lobes, isn't it? You know the shape of this S and P orbital. S orbital is spherical in shape, and P orbital, Px, Py, and Pz, if you draw like this, this is, I'll draw here one of the orbitals. Suppose this is Px orbital having two lobes, and these are directed towards x, y, and z axis respectively, like Px, Py, and Pz. Now these four Sp3 hybrid orbitals, they form, these are equivalent in energy and shape. When these two 1s and 3p orbitals, they combine together on combination on or mixing of these two orbitals, the resulting hybrid orbitals form, they are of equivalent energy and shape. Now remember, this here I wrote that 1s and 3p orbitals, they combine together to form hybrid orbitals. So in all total, there is a combination of 1s and 3p orbitals. So there will be formation of 4 hybrid orbitals. Okay. So now they have one large lobe and one small lobe. This p orbital, this is having one large lobe and one small lobe when they are combined or when the hybrid orbital is formed. And they are at an angle of 109 degrees and 28 minutes with each other in space. Now we'll see diagrammatically how this is forming. How these 1s and 3p orbitals having comparable energies, how do they mix together or recast themselves to form 4 hybrid orbitals. This is s orbital, oriented in a space in this way, plus it combines with Px, Py, and Pz orbitals. So you can draw them separately or you can draw them in combination also. X, Y, and Z orbital. So I'll draw separately for your understanding. This is your Px orbital oriented along x-axis. Then this is your Py orbital oriented along this y-orbit, y-axis, sorry, not orbit. Plus it combines with one more orbit, that is one more orbital, that is Z. We'll draw here. This is Z, Y, and this is X. So these three, which is Px, Py, and Pz. These 3p orbitals and one s orbital, ONE1, not 1s, it is 1s, ONE1, and 3p orbitals having comparable energy, they mix together or they combine together and recast themselves, forming such type of hybrid orbitals. like this. One with the bigger lobe and one with the smaller lobe. Okay, so each of these is sp3 hybrid. Each of these is sp3 hybrid. So in all total, 4 hybrid orbitals are formed on mixing of 1s and 3p atomic orbitals. Okay. Now this small lobe indicates that when it is drawn inside this bigger one, it means that it is pointing towards us. And when it is drawn inside this, like this, it means that this is away from us. Sorry, this is away from us. And if it is drawn in between, it means this is pointing towards us. Now, once the formation of this hybrid orbital is done, let us proceed for the next slide. Then formation of methane molecules. So on the basis of this hybrid orbitals, how this methane molecule is formed. So this can be explained by taking example of methane molecule. So in your exam, you might be asked to explain the formation of either methane molecule or ethene molecule or ethyne molecule on the basis of hybridization sp3, sp2 and sp, formation of methane molecule. In such a question, it carries at least 3 or 4 marks. So just start with this. You are expected to draw this formation, this one. This whole thing, it carries 1 mark. Then write the next thing, that is formation of methane molecule. Start with the atomic number. What is the atomic number of carbon? That is carbon 6. So write down the electronic configuration of carbon. 1s2, 2s2, 2px1, 2py1, and 2pz0. Isn't it? This is the ground state electronic configuration. This is ground state. Now write the excited state configuration, that is 1s2, 2s1, 2px1, and one of the electron from this 2s orbital, it is excited and it occupies 2pz orbital. 2py1. This. This is 2py1 and then 2pz1. So this is excited state electronic configuration of carbon. You know this thing. Now when these orbitals, they combine together, and write the box diagram for this. I will draw here. This is 1s2. This is 2s1. And these p orbitals can be drawn like this. Each one of them having an unpaired electron. So these 4, they combine together to form 4 sp3 hybrid orbitals. So we can draw here sp3 hybrid orbitals. Sp3 hybrid orbitals, when they combine together. So this will remain as it is, 1s2. Then these 4, they combine together to form 4 sp3 hybrid orbitals. Each of them are having an unpaired electron in them. So what are these 4? These are the 4 sp3 hybrid orbitals. So this is expected to write. Remember, this explanation should be there in your answer when the question is asked for 3 or 4 marks, 4 sp3 hybrid orbitals. Then, as I already told, this 1 electron from this 2s orbital here, this 1 electron from this 2s orbital of carbon atom is excited to 2pz orbital. Then 4 orbitals, 2p, 2s, 2px, 2py, and 2pz mix and recast to form 4 new sp3 hybrid orbitals having same shape and equal energy, and each of them contain an unpaired electron. And each of these sp3 orbitals with one electron overlap axially with the 1s orbital of hydrogen atom, because we are talking about the formation of methane molecule. So we should not forget about this hydrogen atom. So these four orbitals having an unpaired electron, they axially overlap with the 1s orbital of hydrogen atom to form one CH sigma bond. And thus the CH4 molecule, we have four CH bonds formed by sp3SO. Now this can be explained by this diagram also. While writing the answer, you should write in wordings the whole thing, whatever I just told. This is given in your textbook, but be very short, be very precise while writing, and I submitted the notes for this also. Then this explanation can be drawn this way. Here you can draw like this. This is the 1s orbital of hydrogen atom, plus it combines with four sp3 hybrid orbitals formed by the overlap of 2s, 2px, 2py, and 2pz orbital of carbon, because we are forming a bond between carbon and hydrogen now. So this is one, this is the second one, this is the third one, and this is the fourth one. Now, so each one of them is sp3. This is also sp3. This is also sp3, and this is also sp3. Then it combines, or it overlaps actually with 1s orbital of hydrogen atom, each one of them. So this diagram is must. Whatever I drew here, everything is must in your answer while writing the formation of methane molecule based on hybridization. Formation of methane molecule by sp3 hybridization. So this is your diagram. This way you can draw. These are the four sp3 hybrid orbitals. Each one of them. Every labeling should be there. And the geometry of this is tetrahedral. Geometry is tetrahedral. The shape of this molecule is tetrahedral. The geometry is tetrahedral shape, like this. This is methane molecule. You can draw this way also, or you can draw this way, CH4. So in this way, this methane molecule is formed by sp3 hybridization. So I'll just take a quick review of this sp3 hybridization here. How these orbitals are formed. 4 sp3 hybrid orbitals are formed. So everything should be drawn like this only. Then how this methane molecule is formed. So there should be explanation about this, including this, whatever is on the screen, with explanation in short. And then this overlap of 1s orbital of hydrogen and four sp3 orbitals, so they actually overlap with the 1s orbital. This is 1s. This is also 1s. This is 1s of hydrogen, isn't it? So in this way, this methane molecule is formed. Now let us start, or let us proceed with the next, that is Sp2 hybridization. Sp2 hybridization. Now, as the name suggests, 1s and 2p orbitals are involved in this type of hybridization. So this type of hybridization, it involves mixing of 1s, or any one, 1s and two p orbitals and two p orbitals. 1s and two p orbitals to give 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals of same energy and shape. Of same energy and shape. This is important. Same energy and shape, or comparable energy, or same energy and shape. Now the three orbitals are maximum apart and oriented at an angle of 120 degrees. And all of them, they lie in one plane. Now I'll explain this with the diagram. This is s orbital. This is s orbital. This is s orbital plus 2p orbitals. So that is 2px and 2py. This is px, x-axis, this is y-axis, and this is z-axis. So this is 2px plus one more, that is 2py, x, y, and z. So this is your y. When these three, they combine together, it forms 3 sp2 hybrid orbitals. 1, 2, 3. One with the bigger lobe and one with the smaller one. So each one of them is sp2. This is also sp2 and this is also sp2. Now in this way, the orbitals are formed and the angle between them is 120. This angle is 120 degrees. Now, in case of this earlier one, that is in case of this formation of methane molecule, this angle, it was 109 degree and 20 degrees. This angle between this angle, the angle between these, this angle is 109 degree and 28 degrees. Okay, this one I forgot to tell about this. Now let us proceed for this formation of C2H4 molecule. That is formation of C2H4. Formation of C2H4 molecule. Formation of C2H4. That is ethene. Now let us start with this carbon with atomic number. Write down the ground state configuration: 1s2, 2s2, 2p, x1, 2p y1, and 2p z0. 2p z0. This is ground state configuration. Then write down the excited state configuration: 1s2, 2s1, 2p x1, 2p y1, and 2p z. This is excited state configuration. I am writing in short. Now write down or draw this orbital notation. Here, the box diagram. This is 2s1 and this remaining, they combine together to form sp2 orbital, and it remains with the fourth one as unhybridized. So these three, they combine together. Okay. Now each carbon atom, it undergoes sp2 hybridization and 1s orbital and 2p orbitals. On carbon, they hybridize to form 3 sp2 hybrid orbitals of equal energy and symmetry. and the two sp2 hybrid orbitals overlap axially. Now remember, this is also very important. You must understand. Now there are two carbon atoms here. In case of formation of ethene molecule, there are two carbon atoms, C2H4. So each one of them will be undergoing this sp2 type of hybridization. I wrote here for the one carbon only. So it is same for the other carbon atom also. So I'll draw this here. The first carbon, it undergoes sp3 hybridization, as we already talked about this. So these are the three sp2 hybrid orbitals of the first carbon. And this is the unhybridized orbital, that is 2pz on the same carbon. This is 2pz. And each one of this is sp2. This is also sp2, and this is also sp2. Okay. Plus, this is for the carbon number 1. Now for the other carbon atom also, it will be the same. 3 sp2 hybrid orbitals. And this is the orbital which is unhybridized, that is 2pz. So you can write here, this is sp2, this is also sp2, and this is also sp2, and this is 2pz, which is an unhybridized. Now they combine together to form such a structure. So this diagram is very important. You write the answer for this. This is very important. Whatever I drew on the screen, this it should come in your answer while writing the answer for this question. How do you form or explain the formation of ethene molecule by sp2 type of hybridization? So this is the sigma bond which is formed, and it also overlaps all these sp2 hybrid orbitals. They overlap with the hydrogen atoms. So this is the 1s orbital of hydrogen. This is also 1s of hydrogen. 1, 2, and here also this hybrid orbital, it overlap axially with the 1s of hydrogen. This also overlap with 1s of hydrogen. Now this one, which is an unhybridized form, this orbital, I'm talking about this one. This is the unhybridized hybrid orbital of this carbon, and this is the unhybridized 2pz orbital of another carbon. So this is 2pz, and this is also 2pz. These orbitals, they overlap laterally to form pi. So this is the pi bond formation. Pi bond is formed. And the geometry of this molecule is trigonal plane. Trigonal plane. So the whole thing should be there while writing the answer. Trigonal plane. Now these two sp2 hybrid orbitals overlap axially to form two s orbital of hydrogen to form sp2s sigma bond. So this is responsible for the formation of sigma bond. This is the sp2 orbital, and this is the sp2 orbital of second carbon atom. They overlap axially to form this sigma bond. The remaining two sp2 hybrid orbital, they will combine or overlap with the 1s of hydrogen atom, 1s of hydrogen atom to form this CH bond, and this is the CC sigma bond. This is also CH bond. This is also a CH bond. Okay. Now the second one bond, which is a pi bond, because there is the valency of carbon is 4. So to satisfy this valency, these 2pz orbital, they overlap laterally to form pi bond. There is a lateral overlap between them. Right? Like this, you can draw, or you can write here. This is the sigma bond. between carbon and carbon, this one I'm talking about. Then remaining is hydrogen and hydrogen, which is formed by the overlap of 1s of hydrogen and sp2 of carbon, 1s of hydrogen and sp2 of carbon. Then the remaining two bonds like this one, this is hydrogen, this is also hydrogen, the same with this carbon also, sp2 of carbon and 1s of hydrogen, sp2 of carbon and 1s of hydrogen. So in all total, there are 1, 2, 3, 4, and 5. 5 sigma bonds are there. They overlap axially. And this one, this second bond, which is a pi bond here, this is formed by the lateral overlap of 2pz orbital. Now remember, this 2pz orbital on the carbon atom, it remains unhybridized here. So it overlaps laterally to form the pi bond. So this pi bond can be shown with the dotted lines. So in this way, there is a double bond between this carbon and carbon, and remaining bonds are the sigma bonds. In this way, this C2H4 molecule is formed. Now let us start with the third type of hybridization. This BF3 molecule is also formed by this Sp2 type of hybridization. You can explain this on the same lines also. Now, we'll talk about this Sp hybridization. For this Sp2 hybridization, I explained it by taking only one example, because the second example is given in the textbook only. So you can read it out and I'm sure you will be able to understand the things. So Sp hybridization, in this type of hybridization, 1s and 1p orbital. As the name said, 1s and 1p orbital undergoes mixing and recasting to form two Sp hybrid orbitals. Two Sp hybrid orbitals of same energy and shape. Of same energy and shape. Of same energy and shape. Okay. Now the two hybrid orbitals are placed at an angle of 180 degrees. So here angle is 180. In case of Sp2 it was 120, and in case of Sp3 it was 109 degree and 28 minutes. Now other two p orbitals, they do not participate in the hybridization, and they are at right angles to the hybrid orbitals. Now this can be explained by taking the example of acetylene molecule, like C2H2, that is acetylene or ethyl. Now acetylene molecule. So start with this configuration for carbon, as I told earlier also, 1s2, 2s2, 2px1, 2py1, and 2pz0. This is 2pz0. This is ground state configuration. 1s2, 2s1, 2px1, 2py1, and 2pz1. This is ground electron excited state configuration. Now, this 2s1 and 2px1 and 2py1, these three, they combine together to form, out of these, these three. Let us rub this one. Yeah. These two, that is 2s and 2px1, these two, they combine to form two Sp hybrid orbitals, and these two, they are remain as it is. So I'll draw it again. This is 1s2 here, then this 2s1 and 2px1, they combine together, and this 2py1 and 2pz1, they remain as it is. That is in unhybridized state. So These sp hybrid orbitals of same energy and shape they are formed, and the two hybrid orbitals, they are placed at an angle of 180 degrees Celsius. And other two p orbitals, these two p orbitals, that is 2py1 and 2pz1, they do not participate in hybridization and they are at right angles to hybrid orbitals. Okay. Now, let us proceed further now. Now, out of these two sp hybrid orbitals, here I'll explain this with a diagram. Now, here, let us start with this s orbital. This is s orbital here. X, Y, and Z. Okay, plus it combines with px orbital. Now remember, both of them, they belong to carbon atom. This is px of carbon and this is 2s of carbon. This is 2px. Now they combine together to form two hybrid orbitals. So these are the sp hybrid orbital formed. Now we are talking about C2H4 molecule. So obviously there will be two carbon atoms. So we'll have to think about both the carbon atoms. So this is for the first carbon atom. These are the two sp hybrid orbitals and plus the second carbon atom. These things remain the same. This is for the second carbon atom. Now, what about this 2py and 2pz orbital? They are having an unpaired electron in them. You can see here in the earlier slide, you can see here 2py and 2pz, these two orbitals. They are having unpaired electron, but they are still in unhybridized state. They do not participate in the hybridization. So they should be drawn like this. This one. Second one here. I like to label first is to avoid the confusion. This is sp. This is second sp hybrid orbital. This is sp. This is also sp. And this is your pz orbital. This is pz. This is pz. And this is py. Same for this also. Second carbon atom. This is your py and this is your pz. Now these two, they combine together. So we can draw here the third one. Here. Same can be drawn. Or you can draw it at the same time. You can omit these two. You can omit these two. So we can draw like this, the structure for this. And for the second carbon atom, this one, this one, this one. These are the py and pz. So here there is a formation of this sigma bond. These two, they overlap laterally. Remember this and this one, they overlap laterally to form the pi bond, and this they overlap laterally to form the second pi bond. So this is pi bond, this is also a pi bond. What are these? This is py and this is your pz. And this is sigma bond. This is your sp orbital. This is also sp. This is also sp. This is also sp. So in this way, and remaining one here, This also overlaps with the 1s of hydrogen. This also, this sp hybrid orbital, it will also overlap with the 1s of hydrogen. This is 1s of hydrogen. And in this way, it forms this one. This is your first sigma bond. This one here, there are 2 pi bonds shown with the dotted line. So you can draw like this. This is the 2 pi bonds which are formed. And this one is the 1 sigma bond which is formed. This is also 1 sigma bond with the sp of this carbon and 1s of hydrogen. This is also sp hybrid orbital of this carbon and 1s of hydrogen. So you can draw this sigma bond in this fashion. So in short, this is the structure of acetylene or ethine molecule. So in this way, this acetylene molecule is formed by using this sp hybridization concept. So we talked about sp3, sp2 and sp hybridization by taking one example. You can elaborate the things by using another example like barium chloride also. Beryllium chloride, not barium, beryllium chloride also. Thank you.